good.
We're live.
All right, guys, we're going to go ahead and get started. I'm Kevin.
And I'm Chris.
And we are Fiveamp. We're a small indie mobile game studio, and we make mobile games. Today, we're going to be talking about best practices in persisting player data on mobile. So this is going to be saving, loading, and the cloud. So what exactly is in this talk? We're going to talk about saving and loading, like exactly what it is. Then we're going to talk about local saves. How do you get your game data into a physical file on the disk? And what are the best ways to do it and the caveats? Then we're going to talk about data integrity. Let's say your save data is now as a file. Like, how do you protect this file? We're also going to go over redundancy. Then we're going to talk about cloud saving, have a slide for a section for additional tips, and then we're going to have time for questions.
All right. So what is saving and loading? This has been around since probably the beginning of games for the most part. But you need a way to persist data between sessions, right? So as old as something like Super Nintendo or NES, where you got your multiple save states on your Zelda game, or something creative like Mega Man, where it's actually not persisting data, but they'd give a user a password, and every time you came back to the app, you'd enter that in, and that would be your game state. So something that we're going to talk about is what you need to consider and what is necessary for your game. So this is going to change from game to game. Do you need save points, something like Resident Evil with a typewriter, and the users go and they start and initiate a save from there? Or are you going to have checkpoints in your game? Are you going to implement an autosave feature in which the game is going to save itself at a certain point in time or just periodically throughout the game? Are you going to allow the player to have multiple save states, similar to Zelda here, where you could have different sessions that you play through? And is it going to be online only, or are you also going to allow for offline saves? This is all something you need to consider when you're crafting out your save strategy. So we'll talk through a few examples, first of which is probably as basic as we can get, is something like Flappy Bird, right? So the only thing they need to persist is a top score. How far did you get? 1, 2, 3, I got to 12. And then when you relaunch the game, you'll see that same save again. And something, Kevin had mentioned it on the agenda slide, we're going to talk a little bit about data integrity. Remember, this is a beginner talk, so we're not going to get too in-depth into this stuff, but we're going to go surface level on a few of these things. So something like Flappy Bird, there's next to no save protection. It's just a plain text file on the device, and somebody could open it up, edit that score from 12 to 20. Next time they launch the game, they'll see their top score is 20. They can go brag to their mom, but it's not that important to the game, right? It doesn't change the game. They didn't get any unlockables. Next level of complexity you might go to is something like Fallout Shelter, cool kind of simulation game from Bethesda. These ones implement local save as well, but they also added cloud save, which allows them to have their saves synced across multiple devices. Let's say you have a tablet and you have a phone, you could play on both devices and keep that same progress going along. This one we market as moderate save protection. There's a kind of a key theme we're gonna illustrate through the course of this talk, is that you can never trust the client. And if you haven't heard that yet, I'm glad to share that with you now, is that if you're putting protected data or data that you care about its integrity on a client, you can never trust that it's going to be safe. So this one, even though they implemented some level of encryption and hashing in their save files, you could still, as you have access to the binary, you can reverse engineer that, decompile it, and figure out how to hack those saves. And then at the top level, something like another mobile game, cross-platform game, Hearthstone, where it's online only. There is no concept of local save. You can't even play the game unless you're connected to the internet. And this one goes to the full degree where they have a first-party account system in which you need to create an account, and that's how you access your data. And all the data is protected on Blizzard's private servers. So we'd mark this one as high save protection, because the only way to really hack your data is to hack Blizzard's servers themselves, which is a whole different degree of difficulty there. And so in talking through these 3 points, you got to kind of figure out where in your game fits in these things. How important is it to you for protection and all of these things? And so the game that we built, we'll talk about a little bit. We launched this a few years ago. It's called PickCrafter. It's kind of an idle, if you're familiar with Cookie Clicker, it's an idle cookie clicker with like a Minecraft theme in it. And we went local save. It was really important to us that our players were allowed to play the game while it was offline. So if they were on an airplane, or if they just didn't have access to an internet connection, they could still play the game in its full glory. And then we also decided to put in cloud save because we needed some redundancy, as well as we would want our players to be able to play across devices. And then we did put in a little bit of encryption as well on our save files, but again, you can't fully solve this one if you're going to support local saves.
So now you have your game data. How are you going to get it to a physical file? we have an example here. Let's say this is your save data. This is Bob's save file, or save data. He has a player name, he has a version string, he's on 2.14. He has some gold, and he has a high score. He also has unlocked the first 2 characters out of 3. So we're going to go ahead and reuse this throughout the presentation so that you guys can see the different utility. So one way that you could start saving data is use player prefs. Who here has heard of player prefs or used player prefs? All right, so yeah, pretty much almost everybody. So player prefs is built into Unity. It is not secure, so we don't recommend storing any important data in player prefs because the player can just easily edit it. But pretty much, use it to store player preferences. So in this example here, we have a music volume. If somebody edits this, or let's say it gets erased, you don't really care that the music volume was changed. How does this look for Bob's save game? So we have his class at the top, and we essentially, what you could do is that PlayPref supports setting a strings, int, float, to it's a key value store. So for each variable that we have here, we're saving, it has a separate line for each variable. As you can see that the more variables you add to your save file, this can actually get more and more complex. And then if you look at the Boolean array at the very end above the save, it gets a little messy too, because now you got to convert this array into a string because player prefs doesn't support writing arrays. And then whenever you load, it gets even messier because now you got to parse this string. So we don't recommend this type of example.
So what's the next level of complexity you can get to? And so what we're going to cover what we call custom saves, which is reading and writing those files yourselves to the disk. Player prefs, what it does is it just saves a plain text file on the user's device, I think in the persistent data path. And so you can do that yourself, and you can create your own infrastructure for doing this. And when you're doing this, there's various formats you get to choose through. We're going to go through a few of those. As far as formats, we're thinking of serialization options. And the nice thing is most of this is built into Unity and supported natively, so you don't have to worry about using a plugin or integrating a third-party library to accomplish this. So where is this data going to go? We mentioned application.persistent data path. This is a nice parameter that's built into Unity that gives you the location of where you should store persistent data. So when the application is closed and it's relaunched, you're guaranteed that this location won't be cleared out, so you can put your saves there. We also want to mention a few locations specific to mobile. If you're on iOS and you want a different location to put your data, you could consider putting stuff in the application plist itself. You could also mess with the iOS keychain. You'd probably have to build a plugin to interface with this in Unity. In Android, there's also a construct called shared preferences, which is very similar. You could save data from there very trivially. So let's talk through the simplest example of how we would save a custom file. We would just need system IO, and then we take our high score from Flappy Bird, and we put it into a string, and we write that text to a file. And then same way, when we're loading it, we're going to take that, read it from that same location, and then parse it back into that integer. So this is a very trivial example, but it does kind of illustrate where you would go and how you get started. So this is customizable. You could do whatever you want. We mentioned bit bashing because if you wanted to make the most proprietary, smallest save file possible, you could be putting all your Booleans into a bit-shifted array and do it as complicated as you want, but this is going to be extremely tedious. In the same way, and in player prefs, if you're using that API in the way that we described it, you'd have to be explicitly massaging every piece of your data into the save file. So where do we go from there? We talked through serialization. So serialization is translating these data objects. So we have our Bob save file, which is a trivial example in this example, and we're going to serialize it into a string. And then what this just means is putting it into a format that we can save to the disk, and then we're going to deserialize it out so we can later reconstruct those files.
So using our same example code, we have Bob's save file and save data, and now we're going to go ahead and we create the save state path with the persistent data path, like Chris mentioned, and we're going to save it as a JSON example.json. And it's pretty simple, actually. You have your game object, and you just do, Unity has a JSON support built in with JSON utility. So it's just JSON utility to JSON save data. And you write this to the file. The file looks like that, JSON example.json, and this is pretty much JSON. So as you can see, we have a high score, we have a gold count, and for those people that are wondering, like, wait a second, that was a Boolean array, JSON utility optimizes and replaces the true or falses with ones and zeros. So that's just something that we're going to cover in a few slides. So that is one format that you can use. You can use JSON. It is readable. It's flexible. We're going to talk about flexibility with versioning later on down the line. But essentially what this means is that whenever you version your save files, because you're going to add more content or even remove variables, JSON is flexible. It doesn't break. It fails gracefully in this situation. And it has a small file size. The next one that you could use is XML. XML is readable, but as you can see, you have the double tags. So it's similar to the JSON in terms of the format, but it adds the double tags. And as you can see, with a large amount of data, the file size is going to be way more bigger than JSON. It's also flexible, too. The other serializer you could use is a binary formatter. Essentially, you get your game object, and you serialize it as pretty much the raw object to a file. It's not readable, as you can tell, and it's not flexible. So if you remove a variable and you try to deserialize that to the same class, that won't really work. It does also have a small file size. And as you can tell here, Bob had like 50 gold or something like that. You can't really tell, and you can't really edit it. So if you were doing some like debug tests and you wanted to edit data on the fly, it's not really doable with the binary formatter. You have to create another tool.
Build your own tools, yeah.
Exactly. So going over versioning, XML and JSON were flexible and binary formatter was not. So this is just an example. Let's say you release version 2 of your app or game, and you go ahead and remove a gold count. You don't need to store a gold count in your save data anymore. So you would increment the version string to 2.15. But in this situation, if you remove a variable and you're using binary formatter, you will run into an issue when trying to deserialize that class. So just keep that in mind when implementing your save file system. So this is a table of just comparing all the formats that we talked about. JSON utility was actually recently implemented, 5.3. The others are built in. And if you look at the size, you can tell that the XML, this is actually a PickCrafter save file that we did this test on. And with the size, XML is 16.1 kilobytes, and JSON was 3.7, and binary formatter was 6.7.
So if you haven't heard of JSON yet, we just want to try and clear up a little bit of that. JSON's a data format. You can think of it kind of more of a specification. And so what this means is there's tons of different libraries, and they implement that specification. So taking a class or taking information and serializing that into that JSON format, that data into that format. And so Unity has one that they built into 5.3. That's the JSON utility that we showed in a few earlier slides. There's also really popular ones available for C# like JSON.NET. And one thing we want to mention is be careful if you're going to swap libraries. They have different performance characteristics. They might have different size. And so you might want to switch at one point or another. But in this case, on the left, we have JSON.NET. And if we had that characters unlocked array, and let's say it was null in one of our save files, and then if we did the same thing with JSON utility, the one that's built into Unity, it's actually going to show it as an empty array, just open bracket, close bracket. So if you were to swap libraries, you'd have to you might have an exception if you're deserializing, or this wouldn't work. So you need to be careful when you're switching libraries and just take that into consideration.
And then some other notable serialization options. There's a ton of libraries out there that you can use. So we have protocol buffers, message pack, YAML, and like Chris mentioned, you have a lot of JSON libraries. Keep in mind that all these have different trade-offs. Some of them might be faster, some might be more optimized. It all depends. Lone Wolfpack Interactive Studios created a blog post a few years ago. They were using, for their save data, they were using XML. And eventually they ran into a performance hit when they were trying to write the save file, and they just couldn't deal with it. So they switched to the binary formatter. The binary formatter was doing great, but then it wasn't as flexible as they wanted to be. They ran into further issues. So they ended up using Protobuf for their serializer. So that's just an example of, like, there's different libraries out there. Just keep that in mind.
Yeah, and one last point on this one. It just really depends, as Kevin mentioned. Like if you're considering sending your save files over a network, or you're sending this information over, XML might not be the right format for you. It's a little heavier, Or if you're just saving to the disk, if that's all you need to do, XML might be fine. It's built right into Unity, and you don't have to worry about anything else.
Yep.
So now we're going to talk a little bit about data integrity. Let's say the save didn't write correctly, or let's say you had something that we're going to call tamper proofing in this case. So if you're using player prefs, or if you were just saving an XML file just to disk like we demonstrated earlier, Your player could jump in, open their data directory, open that file up, edit that high score value, and boom, they just hacked your game. You just lost all your purchases, whatever it was. So you might want to put what we're calling in this case is just a first line of defense. So as we said, you can't trust the client. So if you're saving files locally to the disk, if somebody wants to hack it, if they really want to hack it and they have the know-how, they're going to do it. But you want to put something just as a first line of defense because it might isolate out a huge population that wanted to hack your game but couldn't. So we're briefly going to talk about just encryption and hashing of save files. Disclaimer here, we're not security experts, but we're just going to briefly go over these and go through a basic example. When you go and do it and actually implement this in your app, we recommend you doing ample research and figuring out exactly how you want to do this in your game.
So now we go back to Bob's save file. Let's say we want to make it a little bit more secure. So we want to add in a hash. So the first step is to create the variable, and this variable will hold a hash for the contents of the save file. And what that means is that, so we included some code here. As you can tell, the second line of code where it says save state string, this is where we deserialize it, where we serialize it with the JSON utility, so we have a string of the save file. So instead of writing the save file to a file, what we do is that we go ahead and use the SHA-256 manage included library, and we generate a hash. And essentially where that red rectangle is that we get this hash and we store it in the save data. Now keep in mind, we do recommend adding in some salt or pepper, or whatever it is, please do your research. This is just very
If you're not
basic.
familiar with crypto, those are cryptography terms, the salt and the hash, and this
Yeah.
is where we recommend digging in a little bit deeper and figuring out exactly what these terms are and where they're relevant to you. It's easy as a library implementation, but you want to go a little bit more involved, especially if you're going to be doing this yourself.
Exactly. So now we have this hash and we add it to the save file and we serialize this into a file, and now we have this file. So if somebody goes in here and they modify the high score, and let's say they do 5,000, whenever we load, and we go ahead and generate a hash for that save file, and we compare it with the hash that's in the save file. And if they don't match, then the player has modified his or her data.
So I don't know how many times I've said it so far, but you can't trust the client. So in Fallout Shelter, this is just an example we'll come back to here, they actually implemented an AES CBC encryption. If you don't know what that means, it doesn't matter, but somebody did, and they figured it out, and they decrypted it, put it on Reddit. And then, see, what I want to go over here is that, yeah, it might only have been a small subset of users that were able to decompile a binary, reverse engineer how the hashing was done in the save file, and then edit that file. But this was a popular enough game in which there was a demand for this, and so they actually open sourced the utility, put it on GitHub, and then actually made a web app for it, so anybody could drag in their Fallout save, edit to their heart's content, pop it back out, and put it back into a save directory. So even if you put a complicated hashing algorithm into your game, somebody might release a tool, and it's just you can't fully protect yourself from local. So why even hash at all? Well, it's that first line of defense, right? It's pretty easy to implement. You could probably do it in a day or so, but it is also situational. If you were building a game like Flappy Bird, it's probably not worth your time because it's really not going to affect a player experience. But if you're building a game like Fallout Shelter where it might actually affect your monetization and how your performance is doing, it might be something you're willing to consider. So we talked a little bit about hashing. Another thing that you want to do to build into your save files is redundancy. We've spoke to a lot of Unity developers like ourselves, and sometimes things can just happen in which the save file directory is blown out, or if you had an error in which when you were trying to write that file. If you're overwriting the same file, so in our examples, we're saving to save.dat or save.txt, and if you're just overwriting that same file every time, what if the battery ran out on the phone, however unlikely it could be, or if you're writing a save file that's twice as big and they actually ran out of space and you caused an exception? Either way, you want to retain multiple backup saves. And this one, you can either go to the asset store and find something for this or create it yourself. It's consider like slots. Let's say we have 10 slots and we're just going to rotate. After we save our 10th one, now we're going to save over 0. And also consider you're going to have a custom system on how to fall back on this. If you open a save file and it's incomplete, or you throw an exception, now let's try the next one, and so on and so forth. Something definitely to consider. When talking about saving to the disk, how often are you going to make those save operations? Reading and writing to the disk, as opposed to editing a variable in memory, is actually pretty expensive, and it's completely dependent on the platform that you're using. If it's on PC, it's probably not that big of a deal, but on mobile, it might be a bigger hit. So there's two mono behavior functions that you can listen to: on application pause, on application quit. Pause when they background the app, quit if they close the app out of their multitasking bar or whatever. You can listen to these two functions and then fire off a save there. And that's where I would start. As addition, if you want to implement some kind of auto-saving or checkpointing in your game, consider when you want to do these saves. If you just do it a timer-based way and you're going to save every 5 seconds, is that really necessary? Let's say I was building a puzzle game, and I only really need to save once they've made some kind of significant progress. So consider doing checkpoint-based in that way. And also, if you are considering doing some auto-saving and keeping that without having to have a user interaction on a save file, consider using a background thread. So if you're using a background thread, you can isolate that off, and you won't have any frame hitch when you're doing those autosaves, or do it in between scene loads or something like that in a loading bar, just so you don't have any degradation of performance.
So what are other catastrophic events that could happen? So keep in mind, whenever you're developing your save load infrastructure, keep in mind that anything can happen. And that's what we've experienced too, is like the user can run out of space. Maybe there might be insufficient permissions. The user can, if they had one of those phones with the SD card, they can remove it or unmount it. Maybe they uninstall their app and reinstall it. Also, maybe they just deleted all the files from the directory, or they modified them. We had a couple of people that reached out to our customer service and said, like, oh, my data's not there. And after talking with them for a few hours, they were like, oh, I uninstalled and then reinstalled. It's like, oh, well, you deleted your data.
Right. So in talking about that, especially on the customer service side, be prepared to handle these situations and ones that we haven't listed here, ones that you'll run into. And it's unlikely that you're actually going to be able to reproduce these issues or during your beta cycle or whatever that you're going to experience them, but somebody will. And when they do, make sure that you have, or you've at least thought about a strategy on how you're going to help these people. Yeah. Let's say they spent $20 in your game and they've been playing it for months, and then all their data's gone. What are you going to do? You need to have some strategy in which to hopefully restore this data, whether you have in-app codes you can give to them so they can restore their data, whether you're going to refund them, or whether you can give them a custom save file or somehow manage their account. It's something you definitely need to think through and think about, because it inevitably will happen.
So now we're going to go ahead and talk about cloud saves. Cloud saves introduces a lot more features that would be beneficial. A few of these is that allows the players to have a cross-platform. So like, let's say they have a save on their mobile device, phone, and then they got a tablet. As long as it's the same platform, they can actually load this save onto their tablet. It also can work as a backup to your game, along with local saves.
Yeah, absolutely. So the first one you might look at is something we're calling Platform Cloud Save. These are typically built into the operating system. Something like Google Play Games, if you're using it for achievements or leaderboards already, they actually have a cloud save infrastructure built in. If you're on Apple, if you're deploying to iOS, there's iCloud that's available to you. If you're on Amazon, there's Game Circle, which is packaged in with their leaderboards and achievements. And these are nice because you might already have the plugin in, or you're deploying to that device, so you can easily implement these. Some additional stuff is that they're flexible in the way that when you start implementing Cloud Save, there's a bunch of new problems you have to solve. So let's say I have an iPhone and I have a tablet, I have an iPad, and I play on both devices and I was offline. One of them comes online, pushes to the cloud. I play more offline on that one. That one comes online and pushes to the cloud. It's the same thing that you would encounter if you had a conflict when you're committing to your Git repo. How are you going to handle those conflicts? Most of these platforms have a way that you can configure how you want to handle them, whether you want to code exactly what's going to happen, or if you just want the latest save or the highest save based on this parameter. So you want to keep those in mind. We're not going to go into so much depth as far as how to exactly implement these, but just check out the documentation. They're extremely thorough on how to implement these platform cloud saves. And I know for Unity, there's a plugin built in, or there's a plugin offered by Google for Google Play that you can implement if you're doing achievements. You can just implement Cloud Save. Similarly for Game Circle.
Yep. So what else could you do for Cloud Save? Well, you can actually create your own custom backend. You can use AWS or Heroku, and just have a bunch of servers and have the game saved to these servers. This would be more flexible than the platform Cloud Save, but you're going to need to know AWS. There's a lot of components to AWS. Pretty much, you might even need a dedicated web developer. It all depends. It's not trivial, and it definitely takes a lot of time and work But of course, it all depends on what type of game you're making. If you're making Flappy Bird and you just want to implement cloud save, maybe a platform cloud save is better. Maybe you probably don't even need a custom backend. So it all depends on what type of game that you're making. And whenever I say AWS knowledge needed, definitely need a lot of knowledge of AWS because there's so many components out there.
Yeah, and think about scaling that service too.
Exactly. So the next thing that you could do is that you could implement a third-party backend. So there's a lot of services out there that operate a backend as a service. So for PickCrafter, we chose PlayFab, and it makes it pretty easy to develop. They kind of do all the hard work in the back, behind the scenes. But it could be potentially a higher cost. But essentially what these services do is that they implement, they introduce so many features that you can take advantage of. Like you can manage all your players as player accounts. You can have leaderboards. What else? Like inventory.
Purchase verification, inventory management.
Yep.
Account persistence is a big thing. Let's say you were building a custom backend. How are you even going to identify these players? Is device ID enough? Do you need more of that? Some of these services give you abilities to identify players in which it'd be difficult to build it in your own way.
And also be mindful of mobile device constraints. So people have data plans. Some people might not have a limited data. And if you're like every second sending like a 1 megabyte save file to PlayFab or whatever, that's going to use up a lot of their data. So just be mindful of these constraints. And we just put together a very, very basic cloud save example. Pretty much you have your game data code. You serialize it. Instead of going to the local disk, you make a API call to your custom backend or PlayFab or third-party backend solution.
Yeah, and real quick, just to bounce back on these. So these are, you could think of them as plugins. If you're not familiar with like what these solutions are, how they would work from a development perspective, you would just include, in the case of PlayFab and how we did on PickCrafter, you would just include a C# plugin, and then within Unity you can just make API calls, like I want to publish to player data, or I need to get a token for this user, I need to log him in, and they'll give you a persistence token so you know who that player is, and then you can go and fetch and pull from there. So basically, you don't need a server engineer if you're using these, and you get to do everything client-side.
So now we're going to go over additional tips. We just have a few slides where it could be helpful. So one thing we did for PickCrafter is that we implemented kind of all three. We had local saves, platform cloud save, and we used PlayFab. So here's a scenario. So let's say someone's playing PickCrafter and they spent a lot of hours in this game, and then all of a sudden they uninstall the game, right? But during their playthrough, we were able to manage to save to PlayFab, to their player data. But they uninstall the game, all their data is wiped, but they decide to reinstall it. So what the game does now is on fresh launch, it's all like, hey, let's see if we have any local save files. Oh, no, we don't. Is this a new player or is this a returning player? We don't know. Let's go ahead and contact Google Play. Hey, Google Play, do they have anything in their cloud save? Oh, no, they denied Google Play. They're not even logged in. So now let's fall back to PlayFab. Hey, PlayFab, do you have anything for this device ID? And PlayFab says, oh, hey, yeah, I do. Here you go. It's like, cool. So now the player doesn't have to deal with recovering his data or or restoring the data. It's just works seamless.
Right. And if you were building an online game, for instance, and you only cared about online persistence, you might not need as complicated of a scenario path. Like, let's say it was online only, like Hearthstone, and you wanted to build a basic CCG. You could only talk to PlayFab because they're already going to be online. You know who this person's going to be. It just really depends on the game that you're building.
Yep.
We'll go through a few reminders. Start early on your process. Don't wait until you're all the way done with your app to okay, now I need to put in some data persistence. I want to save this player's data. It's important that as you build your game, you're going to encounter some of these issues and work around them and add redundancy and add cloud save as things go on. So it's important to get started on this early, especially if you're deploying multi-platform. There's very platform-specific nuances. In our case, we actually at last Unite, we ported PickCrafter over to Windows Phone, and we had a nightmare with file I/O, and so we had to completely refactor all of our file I/O because it wasn't supported on Windows Mobile at that time. The file I/O that we used, I think it was .NET 2 or something like that, and so it wasn't supported. So it's definitely important to start early, as well as test on all your devices your save infrastructure, because there's platform-specific nuances that you might have to deal with. To reiterate again that read and writes are expensive, and you need to consider when you're going to be doing these saves and how often. Network usage. If you are going to be saving to PlayFab or saving to another backend infrastructure or sending or making your own API calls to AWS, consider what serialization you're going to be using, because that actually might be a lot more important if you're sending data over the wire as opposed to just to the disk. And something we actually saw, if you just Google online and looking up like people first starting out and figuring out how they're going to persist data, you have people writing code where they're saving every update frame. Don't do that. Yeah. Don't do that. Or if you're sending it over a network, don't save every second. We heard from our buddies over at some of the backend that we've talked to that they'll have to contact their developers on there because, hey man, you're saving every second. This is really heavy.
Yeah. So another thing for Android, Android phones have internal storage and external storage. So these are two different paths where you can save or you could save data to. Internal storage is like a private area, and external storage is a public. And what I mean by that is that if you wanted to open up a file browser and access this data from a computer or whatnot, the phone needs to be rooted to access this. Whereas external, you can hook up your phone and you can grab any files that you want from there. So let's say you have your app, and in the manifest, you prefer saving on the external, right? Now with Android 6.0, they introduced these permissions where they ask you, would you allow this game to write to the external storage? And let's say the player hits deny, then it will automatically fall back to the internal storage. So now, which place do you check, external or internal, for the save data? So that's kind of like something that we've experienced, that we just pretty much check both. There's code online that allows you to get the internal data path, so you can actually check both locations.
Yeah, so this is like a little bit of a step beyond persistent data path, right? Because as Kevin mentioned, depending on what these scenarios are, that application.persistent data path can actually change after an installation. Yeah. In the case that you described, let's say they install and they deny that permission. They deny that permission, it's going to go internal. They launch the game later, it asks for that permission again. They're like, all right, I like this app, I'm going to allow it. Now that routes to a different location. Yeah. And so your data's on internal and you're checking external, and then their save progress got wiped. So yeah, there's code for this, and you actually don't need to create a custom plugin. There's C# code. You can just it'll do the Java classes or whatnot and call and give you that path, and you can check both.
Yep. And another thing we wanted to share with you guys is that by doing having a redundant system, where you could use local files or cloud save or third-party backend, or have different save slots, it allows there's less players losing their data, and which means more happy players. So when we released PickCrafter in October 2014, our ratings kind of went down because our redundancy, we didn't have all the redundancy there. So it kept declining, and we kept pushing out different updates. And then finally, we pushed this update in April 2015, the first exclamation mark, where we implemented we overhauled our redundancy system for our save files. So less players reached out to us about their save data going missing. And then we kind of did more research, and we went the extra mile to do platform cloud save. So as you can see, this, we got less and less complaints, and then we implemented the third-party backend for PlayFab. So as you can see, that it does help. Having these redundant systems will prevent more users from losing their data.
Yeah, so one thing we want to mention is the Unity Asset Store. I'm sure you guys are all very familiar with the Asset Store, but a simple query on the page, and I think we got over 1,700 results for saving. So there's tons of people. This is not a problem that's unique. Everybody runs into it, and so a bunch of people, there's some high-rated reviews on some assets out there. So I recommend checking them out and seeing if they're going to do enough for the system that you're trying to build. If you were just building Flappy Bird, I imagine there's probably a free one on there for you. But depending on as the complexity gets on, you might want to do things your customly or extend their services or implement cloud as well. But definitely check out the asset store and seeing what you can get from it that you don't have to build yourself, because a key thing we want to talk through is to use your time effectively. Maybe you could make the most complicated custom hashing algorithm to try and protect your local saves. Is it worth your time? Probably not. Maybe you could try and create your own serialization method so that it's as small as possible, or you're going to create your own format so you can send it over the wire. Is it necessary? Still, probably not. You want to spend your time on what game makes your game unique. This is really important. Save files are not something super sexy. The only time a user's really going to see them is when they go wrong. So make sure to spend your time on what makes your game fun, what makes it unique.
I think we have quite a bit of time for questions.
Yeah, we did it in a little bit early, so if you guys have any questions, I think we might have a microphone around the room, and fire away.
So with the redundancy you were talking about, can you talk a little bit about how you did rectify the save files? So if somebody did play on one device offline and then came back online and had more progress on another device or whatever, so like checking between those, can you talk a little bit about that?
Yeah, absolutely. So there's a lot of this is account based. So let me repeat the question just to make sure that I got it. So it's a redundancy, but specifically when we're talking about cloud and multiple devices. Okay, so one thing is you need to know a context of who this player is. And this is really important. There's tons of services out there to figure this out, because if a player comes in on a tablet, you have no idea that's the same player. So there's, you could implement something like Facebook login into your app, and so that'll identify them. And then once they log into your game, you know who this player is, and then you can go and triangulate which save file to give it back to that user. If you're using something like the platform cloud saves, that makes this really easy, because if it's in Google Play, that account is already linked up. So maybe a walkthrough would be like, kind of similar to that graph that we had. Yeah, we don't need to bring it back up, but a player comes in. Actually, yeah, maybe it would be good. So let's say a player comes in, they're a new player, and this is on their tablet. They would hit the disk, they'd see nothing, and so we'd check Google Play if they were logged in. Then we would ask Google Play for that save file. They would give us that save, and then we would associate it in. If you were using something like a third-party backend, then you'd need some construct of who this user is. So if they logged in with PlayFab, they would be a new user ID. But if they were also signed in with Google, you could associate that to that user, and then you can bring back those constructs in. It's a little complicated, especially when you get to multiple devices, and how do you know how many devices they have. But if you're using Platform Cloud Save, a lot of these things are already built out for you. Same thing with iDrive. It would be logged in with their Apple account, and you would know who they are. But this is something that you kind of got to figure out, do you want to put this up front in their face? You know, a lot of games you come and you open the app, and there's a login button. And so that's where it's really important to that game that you need to be on the right account. And then there's other games like our game where you get in, you're right into the system, and then we'll actually do background checks. And if we discover that, hey, actually we do have data for this player, we'll present it as a pop-up like, hey, we recovered your progress, do you want to restore? So it's pretty custom in the way you're going to implement it, but there's a lot of services.
Yeah, and something to keep in mind is that whenever we do have data, like let's say they were on another device, and let's say this device didn't have that much of progress, right? But let's say they got a rare item. But the current device they're using, like let's say they're trying to game the system. So whenever this device loads from the cloud and pulls their save file, we check in PickCrafter, since it's an incrementer and you're always gaining points. We check to make sure that the one that we're going to be loading is not behind in progress.
Right.
So we're like, hey, are you behind in progress? Actually, you are, so we're not going to load it.
Let's say you have a gotcha system, and they pay for a premium item, they don't like what they got, they restore from cloud save, and then they just keep doing the cycle. So yeah. There's some things you need to consider for sure when you're building it out, but definitely helps.
Does that answer your question? All right, cool.
Cool. And feel free to come out to us afterwards as well.
Question.
We'll be available.
Yeah, you sort of answered it a bit. My question would be about, you mentioned encryption and hashing is the first line of defense. What other meshes are you doing?
The best thing you can do, if you really care about the security in your application, is to not store it client-side and make sure that it has to be on a protected server. Because honestly, there's tons of things you could do locally, but if somebody wants to hack your game, they're going to hack your game, and they're going to figure it out. They can decompile the binary if they're smart enough, or they can figure it out. So I would recommend, if you want to go to that next degree, you just really need to decide, is this necessary for my game, and how is it really going to affect the performance? One example I can give actually is super popular game, Candy Crush. Widely successful, right? No safe protection, no data protection. You can memory hack that game to your heart's content. Do they care? No, it doesn't really matter. It doesn't affect their performance or their monetization. They focus their energies on what makes their game unique and what makes their game attractive to casual players. And so most people don't do it, and the ones that do it don't affect other people's experiences, right? If you have a heavily multiplayer game, it's going to be really important because if somebody hacks, they're going to make everybody else's experience terrible. But in a game like Candy Crush or a casual game or a single-player game, it's only really going to affect their experience, and in most cases, they wouldn't have paid anyways. Yeah. So can't do much there.
How do you handle data in flight, the encryption of data in flight? Because of course you can save it to disk, or you can move the data structure over to the cloud, but then somebody just opens it up and looks at the payload and then sends the appropriate payload to the cloud save server.
I mean, you encrypt it before you send it over the wire, so it'd be, if they opened up the payload, they would see an encrypted bundle. If you were using something like a handshake, it gets more advanced as far as the algorithms you'd be using. But if you're using a private server, you'd have a key that only your server knows about, and you use something like, I forget what that handshake's called, but you can have encrypted traffic for sure. It's the same as like something as advanced as an SSL handshake down to just a blockchain.
Yeah, and I think a lot of these third-party backends, they already implement encryption. So whenever you're transmitting to the server, so essentially, if somebody really wanted to hack it, they would have to, hack that part of it, and then they see the hash of the save file, and then they have to also hack that. So
yeah, and one thing I'd mention on sending the data over, if your API access if yours is sending over the progress of that user, they could hack the API, figure out what call you're making, and just make their own calls, right? Like if you're saying set gold to 100 from your client, they could say the same thing, set gold to 1,000. So if you're really concerned with making your game secure, it has to be server first, and it has to be server authoritative, in which nothing happens on the client. It's basically a dumb API, and the client just says, hey, I did this, I clicked this button. Not that simple, but hey, I fought this monster. And then the server tells the client, okay, this is what you get. You got 2 gold. You got 5 gold. But if you're doing it on the client, it's never protected.
I have another question. You mentioned that you're able to restore the user progress from PlayFab even when the user has denied Google Play games via a unique device ID.
yes.
So that one is really uniquely computed. So it's more a question about PlayFab probably because they do that that device ID. Or are you doing that?
Yeah, this one can get a little hairy. You have the option to create a custom ID if you want. You could log in with Android, in which that would be the Android IMEI, which is just a construct. I think they might use the advertising ID. I'm not sure exactly what they do, but users can reset this as well. If they completely wipe their device, they might come back with a new ID. So that one, you almost kind of have to fall back on customer service. Or if they link their profile to something that's more persistent, like a Facebook profile, then you're set to go. But in this case, I think it was a device ID. So they uninstall, they still have the same device ID, and then they reinstall, they log in with PlayFab, it's the same person.
Yeah, and something that you could implement too is like Facebook login to your game. So then that ID will always be, unique. You don't have to worry about if someone reformats their phone. They still have the same Facebook.
Right. Same thing for Google Play too, right?
Yep.
Yeah. Google account. Yeah. Oh, back here.
Have you used flat buffers before?
Is that a serialization method, or is it a?
It's a Google flat buffers.
The
Serializing and deserializing. It's
protocol buffers?
It's not protocol. It's flat
Oh.
buffers. It's by Google. It's a
Gotcha.
different serialization.
Similar to.
Oh, okay. I mean, we don't have experience with it.
There's tons of options out there, though. I bet.
Yeah.
I think was it Pokemon Go uses I think flat buffers or proto buffers. One of those two. Google.
Yeah,
serialization.
it's just it's a bit different. It's a lot faster than JSON because there's a little bit of overhead from JSON because you have to
Yeah.
deserialize it
Yeah.
and you're reading in. But I was just curious if you had experience with using it on mobile. But
No, not
yeah.
yet, but it sounds cool.
Yeah, with PickCrafter, we used XML because it was the easiest, and it kind of got the job done. So we weren't really concerned with performance.
When we save to cloud, though, we don't use XML. We have to
Oh, yeah.
serialize with JSON at that point.
Yeah.
But maybe take a look at flat buffs too.
Yeah. Any other? Oh, we have a question.
Oh yeah, we have one back here in this corner.
Just a quick question. When you're using a third-party service like PlayFab, what's the cost associated with that? Is it a per-user cost, or how does that affect your sort of bottom line?
Yeah, they do have a free tier, but I think recently they implemented, it was like based on what features you were using and how, like what was your MAU.
Yeah, most of these services, usually they're pretty flexible, and PlayFab in this instance was, in which they wanted to price it accordingly to your game. But typically there's a pretty generous free tier. So if you're building a new game, definitely like it's not going to cost anything until you reach some level of success. But then beyond that, it depends. But typically it's MAU based. So monthly active users, how many you have on the platform. Some of them could be usage based. That'd be kind of like an AWS infrastructure, which how much traffic are you actually using, and then they charge you that way.
I noticed you had a version string. How do you handle versioning, especially if people are playing on multiple devices where they might have version X on one and version Y that introduced new keys or removed keys on a different device?
That's interesting. So essentially the question is if you had different versions coming from, like you had a 2.15 cloud save, and then also from somewhere you had a 2.14 cloud save, right? That's interesting.
We do. On ours, it's incompatibility. So if we have save files that, so if you incremented your version of your app, the save files might be totally compatible. But if they're incompatible, you could make sure that users update. So if they're connected to the internet and they're actually using Cloud Save in some manner, you can force update those apps. So if we have incompatibility with the Cloud Save or a save format, we'll force those users to update. We'll just put an undismissible pop-up that says, hey, you need to update your app in order to continue playing. That's a super useful thing at some points, especially.
And something you can do is that you could always fall back saying like, all right, hey, if this person's on a 2.15 version, and then here comes another 2.14 version, you can also, there's a lot of things you could do. You could also look at their progress, or you could just flat out say like, hey, if this person has progress on 2.15, and here comes a 2.14 save, there's a lot of things you could do. You could just deny it, or you can look at the data and compare. Right now for PickCrafter, we just, since we're just using like a one channel for third-party cloud save, we just use it as like more of a backup, just in case of their data wipes.
Yeah.
So.
If it was like if it was an old client, it talked to the cloud and got a new save, we just compare the version strings. And so it'd be like, this client doesn't know how to handle the new client save, and it wouldn't load it. It would just keep on whatever it had. Any other questions?
Yes.
Quite a bit of questions.
So for the graph you showed for why you ended up going with the redundancy, so it...
no, it's...
No, that was...
Oh, that was it? Okay.
Yeah.
Oh.
So I see why you went with platform cloud saves, like you started, the rating started going up. But it seems like for when you chose PlayFab, like it was already going up, like things were good. I'm curious what made you go with it, and what are there features that it had that the platform cloud saves didn't? Like what were you looking for there?
Yeah, so when we shipped PickCrafter, we had Google Play, for Android, we had Google Play leaderboards and achievements. We weren't using the cloud save. At the same time, for our game, we don't have the pop-up to log into Google. We only do it, we ask them in game saying like, hey, would you like to enable achievements? So there could be a scenario where someone's all like, no, I don't want to enable achievements. I don't want to log into Google. So if they're not logged into Google, then it's like, oh, snap. We pretty much have no cloud save protection for that user. Whereas third-party backend, we get their device ID automatically, and now we associate that to a PlayFab user.
Right. And then it gave us the addition of also being able to craft a more complicated system that allowed us to play iOS and Android at the same time, when we didn't want to ask iOS users to log in with Google, because it was unlikely we're going to get a good threshold. So we have if they want to play across, they can log in with Facebook and we know who they are, and then PlayFab can orchestrate where the save file is, and they can play on both.
And also a cool thing with the third-party backend, like for PlayFab, since we're storing the user's data in PlayFab, they offer a lot of features. We started out with IAP validation. They do a really good job with that. But then now, since we have the user's save data in PlayFab, we just log on to a control panel. And let's say someone's all like, hey, my save data is busted or something. We could generate a save and we could put it in the user's save data, like location.
Gives
and
you
then,
more like customer service
exactly, yeah.
capabilities too.
Yep. Any other questions?
So the Google Play or the PlayFabs, did they have administrative tools for you to view or edit any users' content?
So for Google Play, you can't. You can't view a user's save files from an admin perspective. For PlayFab, though, you can. You can look up, as long as the player gives you some sort of information, whether it's their PlayFab ID or device ID, then you can just search, find their data, and go from there. But with Google Play, it can get a little bit.
I think you could delete. I think that's about all you can do. Same thing with leaderboards. Like you can remove, but you can't.
Yeah, you can't really change. It's kind of locked down. So that's what we're talking about with the flexibility.
Closed system.
With the third-party PlayFab, we can.
Okay, so you can run any reports off of that to say your score of 1,000 is better than 80% of other players, or in the example save data set that you had 3 unlockable characters.
Yeah.
Mm-hmm.
If you were to add a 4th, you couldn't batch those to add a 4th parameter on there of false to every user as you were rolling that out.
Oh, I see. In that case, what you would do would be if you were to add in a new, this is what you're discussing, essentially if you have a new version, 2.15, and 2.14 had 3 characters, then you check to see what version they're coming from, and they're like, oh, they're 2.14. We need to do this additional logic to, compensate for that.
Okay, so that would be done on the client side. You couldn't.
Correct, yeah. Because going through each, I don't think PlayFab has the tools to modify old players' data. Do you know?
Yeah, they do.
Okay, to do a batch.
You can do cloud code and you can execute on everything.
Oh, yeah.
If you needed to do something like audit your entire, it'd be expensive. You might have to contact them depending on how big your user base is. But you could run JavaScript against your everything. You have full authoritative server access, and you could write some JavaScript to do whatever you want.
Yep.
And if you were piping it out
and run it off server.
On server, yeah.
Yeah, they have a feature called CloudScript and allows you to write JavaScript to execute on their system, which
in a
is
protected
cool.
environment. Yeah.
Yeah.
Okay, thanks.
Yeah.
Hi, hello. I have a question. So, how do you guys solve the problem for maybe 2 player or 2 device will operate the same user profile at the same time? For example, I have a device, and I have a PlayFab account, and then I link my Facebook account to the PlayFab account, and then I use another device to run the game by using the Facebook, while I using the old device connect to the PlayFab by using the IDFV. Then there would be a conflict, right?
Yeah.
How do you guys deal with it?
This is a pretty common question that PlayFab developers have gotten.
Right. I know a lot of ways developers implement this is if you do it let's say on a Hearthstone, it would say your session's being closed, do you want to force close? And you kind of have a semaphore, a locking, right? And so only one client can have it at a time. If a new client comes in, you say, hey, I'm going to kick out your other client. It's usually more popular for offline games. In our game, we wouldn't necessarily click or kick them off or say you couldn't play. They would just be competing with each other to save, and every time there was a conflict, they would have to manage it. It's kind of similar to Fallout Shelter. I think they do it where they give the conflict management to the user, and they say, hey, here's your 2 saves. This one's on level 5, this one's on level 6, which one do you want to use? Yeah. So in our case, they both would be saving, but whenever there was a conflict, it would ask the user to figure it out.
Yeah, because if you just fall back on saying hey, let me just take the latest one. What if that one's a totally empty game, So.
And so does that mean I need a manager to manage the conflicts?
Correct. Either by presenting it to the user or having another different system manage the 2 files.
Yeah, I would say you'd have to have something checking in and saying hey, my session's active, or having something holding it, and then when a new client comes in, you say, no, I already have an active session, and then you need to handle it from there. Say, you're not going to play, or do you want to take over?
Okay, thank you.
Yep. Awesome.
Thanks.
Thanks.